Hi everybody, welcome to number theory. This is chapter 4. So we are done chapter 3. We are done with chapter 3. In chapter 3, we talked about 4 operations: addition, subtractions, multiplications, and division in whole number system. So let me quickly review what whole numbers are. Whole numbers start from 0. And then you put counting numbers, which are 1, 2, 3, 4, 5, 6, 7. If you have only 1, 2, 3, 4, 5, 6, 7, 8, they are the counting numbers, or we call that natural number. If we add 0 to that, it becomes the whole number. So we don't count any negative numbers yet. If you add negative numbers, it becomes integers. But we are only talking about whole numbers here, okay? So we are not done with the whole numbers yet, still working with the whole numbers, and we're gonna have number theory on the whole numbers. Okay, so in this chapter we're gonna do these 3 sections: divisibility, prime and composite numbers, greatest common divisor, and least common multiple. So you can have some expectation on what you need to do. Okay, so the first thing is the divisibility. So divisibility, you can think about what divides what. Like 2 divides 6, right? Because 6 is divisible by 2. So we're gonna talk about those relationship, and we're gonna find some rules. Like, is there any number consistently divides by 2? How about divisibility by 3? How about divisibility by 5? And so on. So we're going to talk about that. So I want you to consider with these 2 numbers, 2 and 12. You already see some relationship there, right? I want you to pause the video and fill in each of these blank using 2 and 12. So what comes? 2 comes here, or 12 comes here, and the other one. So solve the problem first, and then come back. So I'm pretty sure you have already solved it, and compare my solution with your solution. Okay, what is divisible by what? What is divisible by what? Yes, 12 is divisible by 2. Then what is a divisor of what? Divisor is a number that is dividing. So 2 is a divisor and 12 is the dividend, right? So we can say 2 is a divisor of 12. Then what is a multiple of what? So when you're multiplying something, you get this number. So 12 is a multiple of 2, because 2 times 6 is 12, right? So 12 is a multiple of 2. What is a factor of what? Factor is a smaller unit, so we can say 2 is a factor of 12. What divides what? 12 divides 2, or 2 divides 12? Yes, 2 divides 12. So we know the relationship between 2 and 12 using a lot of different ways of expression. So what's the definition of divise? For any whole numbers a and b, where b is not 0, but a can be 0, b divides a if and only if there's a unique whole number q, the quotient, such that a is equal to b times q. Then we can say b divides a. Okay, b divides a. Or a is divisible by b. Or b is a divisor of a. Or you can say a is a multiple of b. B is a factor of a, or b divides a, right? We can use a and b using these words. Okay, the notation for divise is this. It's not slant, right? It's a straight down. So b divides a. B divides a. That's different from a divided by b, or b divided by a. Okay, that's not. This is rather a slash b, a over b, because A is the dividend and B is the divisor. So if you change that to fraction, it's not B over A. Be careful, okay? This is rather A over B. B divides A. Because A is equal to B times any quotient. Okay, so B is the divisor and A is the multiple. Okay, the divisor is a factor as well, right? So we can say B is a factor of A and A is a multiple of B. We read this notation as B divides A. So B is a smaller number, A is a bigger number, like 2 divides 12. Okay? Alright, now we have an example here, and I want you to answer this question with a true or false. By pausing this video, answer your own first and come back. Okay, so let me actually copy this down and have that on the Jamboard. Hold on, that's not quite. Okay, so where's my Jamboard? Here we go. Okay. Okay, so these are the questions you have. Let's answer each of them together. Alright. Let's think about this one first. 3 divided by 12. 3 divides 12. Does 3 divide 12? True or false? Yes, it is true because what? 12 is equal to 3 times what? 4. So 3 does divide 12. So yes, it is true. How about this? 0 divides 2. Does 0 divide 2? So does 0 divide 2? No, it doesn't, right? Remember? When your denominator, the divisor is 0, it's undefined. If you remember from last lesson of whole number division, it is false. You cannot divide any number by 0. So 0 cannot be a divisor, right? Okay, how about this? 0 is even. Is 0 even? If it is even, it's always divisible by 2. So let's see if 0 is even. Can we have 0 is equal to 2 times something? 2 times 1 makes 0. 2 times 0 makes 0. Yes, so we can say that 0 is even because it is divisible by 2. How about 8 does not divide by 2. 8 does not divide 2. 8 is not a divisor of 2. What do you think? Is this true or false? It is true because 8 does not divide 2. 2 divides 8, but 8 does not divide 2. So it is true, right? Okay, how about this? For all whole numbers A, 1 divides A. So A is divisible by 1. Yes, A divisible by 1 is always A. So yes, it is true. How about F? For all non-zero whole numbers A squared divides A fifth. So that means A to the fifth is divisible by A squared, right? So A to the fifth means A times A times A times A times A, or multiplication over A times A. So what do you see? You can cancel these A's out, and you have A cubed. So yes, there is a quotient when you divide A to the fifth with A squared. So yes, it is divisible. So A squared does divide A to the fifth, right? So it is true. How about G? does 3 divide 6n? So does 3 divide 6n? Yes, it does, right? For any whole number, because we can see that 6 is divisible by 3. Divide both by 3, you get 1, you get 2. There's always 2n. So yes, 3 does divide 6n. 3 divides 6n is true. So here, one thing you need to be careful is like this. 3 divides 12 is the same as 12 divided by 3, because 3 divides 12. Not 3 goes up here in the fraction, okay? That's different from the fraction notation. Be careful. So if we do 3/12, that means 3 divided by 12. So that is actually 1/4. So be careful about this, okay? So straight down is this divides. That actually, that number, first number goes to the bottom, the denominator. Okay? Now let's look at h. Does 3 divide 5 times, 7 times, 9 times, 11 plus 1? Well, this is in the parentheses and it's not calculated yet. So we need to take a look at the final answer for these. What's 5 times, 7 times, 9 times, 11 plus 1 divided by 3. There are two ways. You can either find the answer for this by multiplying 5 times, 7 times, 9 times, 11 and then add that by 1. You can do that. But I don't want to do that because I don't have a calculator and it takes some time. So instead, what I'm going to do is I'm going to separate these two terms, because you have two terms. This term as a product and add that by this term. So you have both with the same denominator, but this part is 5 times, 7 times, 9 times 11, and this term is 1 over 3. 1 over 3 is of course not 1 is not divisible by 3 because it's less than 3. But here I see that it is divisible by 3 because 9, one of the factors of these numbers, which is 9, is divisible by 3, right? So I see that that's same as 5 times, 7 times, 3 times 11 plus 1/3. This number plus 1/3 is not of course divisible by 3. So this whole thing is not divisible by 3. So yes, it is true. Make sense? Okay. And 0 divides 0. This is the same as this 0 divided by this 0. That's this 0 divided by the first 0. Think about this. In the division, we said if you have a denominator 0, it's undefined, right? So of course you cannot have 0 dividing 0. So whenever you have a 0 divides something, like part B here, 0 divides, that's undefined and that's false. 0 cannot divide anything. Okay, 0 divides doesn't work. For all non-zero whole number, then a divides 0. So that's same as 0 is divisible by a. Yes, it is 0, right? So yes, it is true. Okay, so you can always relate this divisibility with fraction, right? Like that, the division, but you need to put the first number as a divisor, which means it goes to the denominator, not to the numerator. So be careful about that. Okay? Alright. Now, let's look at, here are some solutions so you can find the right answer. Now, I want you to think about the divisibility by 2, 3, 4, 5, 6, 8, 10, and 11 for each of these numbers. Okay, let me pause the video. Let's talk about the divisibility here. So I gave you 5 numbers and I wanted to check whether each of these numbers are divisible by 2 first. So which one is divisible by 2? What do you know? Some may say that if it ends with any even numbers like 6, 0, here only 2 of them are even numbers, then it is divisible by 2. How about divisible by 3? Is it divisible by 3? You may actually divide 516 by 3 and see if there's no remainder there. Then it is divisible by 3. You can do the same thing for 4, 5, 6, 8, 9, and 9, 10, and 11. You can do all about that. But if you do that, I mean, it works, but it kind of takes too much time, doesn't it? If we know a rule, just like, well, if it's an even number, it is divisible by 2. Then it's so much easier. You don't have to actually divide that by 2. Because you already know that it is divisible by 2. If it is not an even number, then it's not divisible by 2. You already know the rule, so it becomes so much easier, right? So here we're going to talk about some rules. And this is a 100 chart. We use this a lot when we're talking about divisibility. For example, you can find a pattern in this 100 chart. So like divisible by 2 is always the even number. So you can circle all the even numbers. So every other number from 2, they are divisible by 2. How about divisibility of 3? 3 is divisible by 3, so we can circle 3. How about I actually put this in Jamboard and we do that together. So let me bring that up. Okay, so I got that. Let me put it on the Jamboard here. Okay, let me make it bigger. So we know all the divisible number by 2. Let me mark it with green. Is it blue? Blue. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All of these. So I see that, all of these numbers in this row, the column, and all the numbers here, 4, 14, 24, 34, 44, 54, 64, 74, 84, 94, 6, 16, 26, 36, 46, 56, 66, 76, 86, 96, 8, 18, 28, 38, 48, 58. All of these are even numbers and they are divisible by 2. Right? They are divisible by 2. So 2 divides any numbers here. How about divisibility of 3? Let's think about that. I'm going to use this highlighter. Okay, so 3 divides 3, and 6 does, then 9 does. So every third number, right? 3, 6, 1, 2, 3, 9, and 1, 2, 3, 12. 1, 2, 3, 15, 1, 2, 3, 18, 1, 2, 3, 21, 1, 2, 3, 24, 1, 2, 3, 27. So your students can mark all the numbers that are divisible by 3, 1, 2, 3, and they can see the pattern there. So if I continue doing this, you can also see the pattern here. What do you see? Oh, I see the diagonals here. So without even looking at, without counting the third number, I can automatically see these numbers are divisible by 3. Diagonal number, diagonal number, diagonal number. Like these. These are divisible by 3. Right? So they can find the numbers. They can also do the divisibility of 4, 5, 6, all of that. So 100 chart is very, very useful and I like it so much. Okay, and then we can talk about the divisibility test. So here are some rules. As you already said that divisibility by 2, if the last digit, the unit digit, is even number, which means if that is divisible by 2, then the whole number, that whole thing is divisible by 2, right? So if that number is even number, it is divisible by 2. How about divisibility by 4? Divisibility by 4, you need to look at 2 digits from the right. So again, divisibility test for 2, you are looking at the only ones digit, whether it is even number or not, whether it is divisible by 2 or not, right? For divisibility test for 4, you need to look at 2 digits. So you need to look at last 2 digits, whether it is divisible by 4 or not. That works because think about 100. If you have a 0, 0 there, it is divisible by 4. Then you can extend that to divisibility test for 8. So 2, 4, 8. For 8, you need to look at 3 digits from the right hand side, from the units, tens, and hundreds together. By looking at that, if it is divisible by 8, you can say it is divisible by 8. Okay, so here are some examples. Determine whether 97,100, let me write that down, 97,128 is divisible by 2, 4, and 8. And I want also you to look at 83,026 is divisible by 2, 4, 8. So while I go to Jamboard, I want you to check that divisibility, okay, of those two numbers. So we have these two numbers, 97,128 and 83,026. Okay, so to find whether these numbers are divisible by 2, we're gonna look at the ones digit. It is divisible by 2. So yes, it is divisible by 2. So 2 divides that number, 8, right? And here we are looking at the ones digit. 6 is even number. So yes, 2 divides 80,026. How about 4? You need to look at 2 digits. 28. Is 28 divisible by 4? Yes, 4 divides 28. So even without dividing this big number by 4, we know that 4 does divide 97,128. Now look at 26 for divisibility for 4. 26 is not divisible by 4. So 4 does not divide 83,026. Okay? How about divisibility of 8? Let's think about 8. To consider divisibility of 8, you need to look at all 3 digits, 128. This is so much easier to divide it by 8 than 97,128 by 8, isn't it? So if you do that, 8 times 1 is 8. I'm just doing the long division. Let's actually practice the partial quotient. So 8 times 10 makes 80. And if you subtract it, you can have 8 minus 0 is 8, 12 minus 8 is 4, so you have a 48. And I have 8 times 6 is 48, so the remainder is 0. And the quotient is 10 and 6, so actual quotient is 16, right? So yes, 8 divides 128. If 8 divides 128, all 3 digits, then 8 does divide 97,128. So 97,128 is divisible by 8. and it's also divisible by 4, and it's also divisible by 2. Actually, if this number is divisible by 8, it's also divisible by 4, and that's also divisible by 2. Because 4 is a factor of 8 and 2 is a factor of 4. However, that doesn't mean that, if a number is divisible by 2, it's not always divisible by 4, as in this case. How about divisibility by 8? You don't even have to do that. If it's not divisible by 4, it can't be divisible by 8. So 83,026. Look at the 3 digits, 026. 026 is not divisible by 8. So no. Okay? So again, if a certain number is divisible by 8, it is divisible by 4, and it is of course divisible by 2. But not the other way around. Not always. Okay? Alright. Good. And let's look at the next one. Let's look at divisibility. Here, this is what I had just said. Show that if 8 divides A, then 4 divides A, and 2 divides A. But the converse is not true. We just showed that example, right? So I want you to think about the counter example. Give me a counter example. The previous problem was the counter example. 83,026 was the counter example. Can you think about another counter example? The converse. The converse is if 2 divides A, then 8 divides A, and 4 divides A. So let me actually write that down for you. Okay, so so what we have here is the original statement is if 8 divides A, then 4 divides A, and 2 divides A as well, right? That's the original statement. What's the converse? Converse of that is, we learned about converse in Math 137 long time ago. The converse is this: if 4 divides A and 2 divides A, then 8 divides A. We say this is a false statement, even if this is true statement. So to prove the false statement, we can always show the counter example. We did this in Math 137 as well. Counter example. So when you are picking the counter example, you need to make that example true for if statement, but false for then statement, the conclusion. Okay? So like if you pick 4 as an A, 4 divides 4, yes, and 2 divides 4. So it is true for if statement, but does 8 divide 4? Does 8 divide 4? No, it doesn't, right? So this is a good counter example that makes this converse statement false. Okay? Okay. Now, I want you to look at this Venn diagram. You can see the subsets here. So any number that is divisible by 8, then it is of course divisible by 4. And of course, any number that is divisible by 4 is divisible by 2. But not always the other way around. Like a number here, like 2. 2 is divisible by 2, but 2 is not divisible by 4. But like 4 is divisible by 4, and 4 is divisible by 2, but it's not divisible by 8. Okay, so you can see the relationship here as the subsets. Alright, and we have a little more to go. And let's think about divisibility test for 5. Yes, you already know, right? So if the last digit ends with 0 or 5, it is divisible by 5. So like 5, 10, 15, 20, 25, 30, all of these numbers are divisible by 5 and they end with 0 or 5. How about divisibility test for 10? So if you think backwards, multiples of 10 is like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Those all ends with 0, right? And they are of course then divisible by 10. So whenever you have 0 in the ones digit, then it is divisible by 10. So divisibility tests for 5 and 10 are pretty easy too. Next one is divisibility test for 3. This is an interesting one. So we already looked at the numbers in 100 chart, right? The whole numbers like 3, 6, 9, 12, 15, 18, 21, these numbers are divisible, that numbers are divisible by 3 if and only if you add those digits together and it is divisible by 3. Okay, I'm gonna give you the example. But similarly, divisibility test for 9, you add all of the digits together, dealing them as a single digit, and if the sum is divisible by 9, it is also divisible by 9. So we're gonna have some examples here, okay? And I will explain that to you. So we have two numbers, 1002 and 14,238. So let me have this jumbled again, and let's think about the divisibility test of 3 and 9. So you have two numbers, 1002, 14,238. They are not divisible by 5 or 10, right? Does not end with 5 or 0. It's not divisible by 5. Doesn't end with 0, so it's not divisible by 10 as well. Let's think about divisibility test of 3. So does 3 divide them? Does 9 divide them? To find it, what you need to do is you're gonna add each of these digits. So 1 plus 0 plus 0 plus 2. And look at the sum. That's 3. Is it divisible by 3? Yes. 3 divides 3. So it is divisible by 3. So you can say, yeah, 3 divides this number. How about divisibility test of 9? You do the same thing. So you found the sum as 3. Does 9 divide 3? No, it doesn't. So 9 does not divide 1002. Let's do the same thing here. 1 plus 4 plus 2 plus 3 plus 8. And I'm going to have comparable numbers here. 2 and 8 is 10. And we have 1, 4, 5, and 3. So altogether, it's 18. The sum is 18. Sum of the digits is 18. Does 3 divides 18? Yes. Then it is divisible by 3. Does 9 divides 18? Yes. Then this is also divisible by 9. So we can say 14,238 is divisible by 9. Okay? That's how you do it. Okay. So we learned, wow, divisibility test for 2, 4, 8, 5, 10, 3, and 9. Wow, that's great. Now let's think about divisibility test for 11. 11 is a little bit tricky. And let's read the description from the textbook, if you can understand that. A whole number is divisible by 11 if and only if the sum of the digits in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10 is divisible by 11. It's kind of lengthy and confusing, right? So I will give you the examples a little bit later. And think about divisibility test for 6. If a whole number is divisible by 6, if and only if that number is divisible by 2 and 3. It has to be divisible by both 2 and 3. So let's have some example. How about we use the same number for divisibility test for 11. Let's do that first. Okay, so I'm going to bring the Jamboard here. So we have two numbers, 1002 and 14,238. So the divisibility test by 11, dividing by 11, when you are finding that out, you're gonna look at even number power. So even digits like these, add them together, 0 plus 2. And look at the odd number of digits, so 1 and 0 together, 1 plus 0, and find the difference of these two. So even numbers, the order doesn't matter, whichever with bigger number you can do that. 0 plus 2 is 2, 2 minus 1 plus 0, 1 is equal to 1. 1 is not divisible by 11, so it's not divisible by 11. We can do the same thing here. So add all the odd numbers of digits, 1 plus 2 plus 8, 11. And even digits, 4 plus 3 is 7. The difference is 4. 4 is not divisible by 11, so you can say 11 does not divided by 11. Okay, how about some actual number that is divisible by 11, like 121. 121, we know that 11 times 11 is 121. And let's look at this. So 1 and 1, every other number, right? So 1 plus 1 is 2 minus the other number, 2. That's 0. Do you remember about 0? Yes. Any number does divide 0. Yes. That means 11 also divides 121. I will give you one more example. Let me find the number. So something like 11 times, how about this big number? I got 47,916. I already know this is 11 times 4,356 because I used my calculator. So it is divisible by 11. We're gonna test it if it really works. So you're gonna add 6, 9, and 4 together. 4 plus 9 plus 6 is equal to, what is it? This together is 15. And 15 and 4, 19. 19. And other numbers, 7 and 1. 7 plus 1 is 8. So find the difference now. 19 minus 8 is equal to 11. Yes, 11 is divisible by 11. So we can say, yes, 11 does divide 11. That means this big number is divisible by 11. So you can save time doing 47,916 divided by 11. It takes so much time and you can make mistake too, right? But doing this test for divisibility, it's so much easier. Even if we cannot find what the quotient is, at least we can find out it is divisible, and 11 is a factor. So later when you have to factor this number, you can do 11 times 1 makes that. You can do that. Okay, so that's the divisibility test for 11. And let's talk about divisibility test for 6. So another example that we can do is something like 36. I know it is divisible by 2. It's divisible by 6 because 6 times 6 is 36. And then when you're testing really big number, like let me give you another example. 167,688. I just got this. And I know that this is divisible by 6. how can we test it? You need to test by divisibility of 2. Is this number divisible by 2? And it says and it's also divisible by 3. So we're gonna find that out. So to test to test the divisibility of 2, we just look at the last digit whether it's even or not. It is even, right? So yes. For this, how about divisibility of 3? We just need to add all of these two together. So 1 plus 6 plus 7 plus 6 plus 8 plus 8, right? So I know the double of this is 12, and I know double of 8 is 16, and I have 1 and 7 is 8, and this is 20 and 16, 36. 36 is divisible by 3, right? So it is divisible. Then we can say this is also divisible by 3, because 167,688 is both divisible by 2 and 3. We can say it is also divisible by 6. Okay, just like this one. 2 divides 36, 3 divides 36. Then 6 divides 36 as well. So that's the divisibility test for 6. So we now know divisibility test for 2, 4, 8, 5, 10, 3, 9, 6, and 11, right? So we got that. We got this number already, right? Then you can determine whether this really big number is divisible by each of that. So pause the video again and think about all the divisibility tests for each of these numbers. Okay, let me copy that down. 7, 2, 9, 3, 6, 4, 5, 8, 3. We're gonna do the test for all of these numbers. Okay, so let's go to this Jamboard again. Okay, let me write down our big number. 5, 7, 7, 2, 9, 3, 6, 4, 5, 8, 3. How do we read this number? Let's put some commas. I think that helps us read it easily. It's 57,729. Oh no, I did it wrong, right? 57,729,364,583. Okay, it's really big number, right? Let's think about 2 divides this number. I'm not gonna write it, okay? I will just say that's an A, and I will say, does 2 divide the A? Yes or no? No, because look at the last digit. It's not an even number, so no. Right? How about 3? Does 3 divide that number? To have the divisibility test for 3, we can just add all of these digits. So we can do 5 plus 7 plus 7 plus 2 plus 9 plus 3 plus 6 plus 4 plus 5 plus 8 plus 3. For a big number like this, it takes some time when you're adding the digits as well, but it's still so much shorter time than you divide this by 3. Don't you think? Yeah. Any comparable numbers do you see? 6 and 4? That's 10. 5 and 5, another 10, 2 and 8, 10, 7 and 3, 10, another 7 and 3, 10, and I have 9. So I have 1, 2, 3, 4, 5, 59. Is 59 divisible by 3? No, it's not, right? 3 times 20 is 60. 59 is only 1 less, not 3 less, so it's not. So 3 does not divide A. Then we can do the divided by 9 too, right? So 59 is divisible by 9? No, it doesn't divide. because 9 times let's see, 9 times, what's close, 7 is 63. How about 9 times 6? That's 54. 59 is in between these two numbers, so 9 doesn't divide that big number. So we are done with that. But we also know that 6 does not divide A as well, because it's not divisible by 2 or 3, right? How about divisibility by 5? Of course not, because it doesn't end with a 0, and we know that it doesn't work for 10. What did we miss? Oh, 4 and 8. So 4 goes here, but I will just write here 4. So we need to look at 2 digits, right? 83. Is it divisible by 4? No, it's not. Well, if it's not divisible by 2, it's automatically not divisible by 4 or 8, right? Okay. So I think we are done. Oh, 11. We didn't do 11. So let's think about divisible by 11. We need to look at every other number and add them together. So let's add all of these numbers together. Any comparable number? 5 and 5, 10. Anything else? 6 and 3 is 9, 9 and 9 is 18. Then I still have 7. So together, 18 and 7 is 25, and I have 10, so 35, right? And if I use rule for these numbers, 7 and 10 together is 7 and 3 together is 10, and I have 2 and 8, another 10, and I still have 4 there, so that's 24. Let's look at the difference between those two. So 35 minus 24 is equal to 11. It is divisible by 11, so this big number is only divisible by 11. Okay, so it's not a prime number then. We'll talk about that later. Okay, so we did divisibility test, and I'm pretty sure you know how to do it now, right? Okay, that's it for section 1, and next time we will do the prime and composite numbers. Be excited. Okay, thank you guys.